Hi everyone. Today I'm going to be machining some unique custom knobs for my electric bass. This is a bass that I'm building from a kit, and it has a lot of really generic looking parts, so I want to try to give it as much character as possible. With that in mind, I have some really cool ideas, so stay tuned for future videos. Enough talk, let's get into it. These are the knobs that came on the bass, and I'm going to be replacing them because I want something a little bit more unique, something other than just the knurled thing. But I'm going to be making them the similar way. These are a metal shell with a plastic core, and I don't have the luxury of being able to injection mold the inside, so I'm just going to machine it out of plastic, and I need to know what size hole to drill in there. So to get that, I'm going to mic the outside of the pot, and the pot itself is serrated. It's got these splines on it. So I'm going to split the difference between the size of that hole and the size of the pot. The outside of the pot's coming in at 233 thousandths. It's probably 6 millimeters, which is 236. And then the inside of the hole, I'm going to use gauge pins. I've already done this off camera. The 219 thousandths pin just starts at the very top of the hole, or bottom depending on how you look at it, and the 213 bottoms out. So I'm going to split that difference. It's really close to a 7/32 drill bit, and that's going to make a slightly oversized hole, but the serrations, the splines on the pot, are going to displace a little bit of that plastic, so I should still be able to push it on. Remember how incredibly important it is to get your dimensions correct. Since these are the volume and tone knobs for the bass, the only suitable number of flutes should be 11. Hashtag Spinal Tap, hashtag One Louder, hashtag Smell the Glove. I'm eventually going to put a crown on the end of the knobs after I machine the flutes, but I don't want to do that just yet because I need to set up a stop on the mill to keep the same amount of stock sitting out of the dividing head. So to make that easier on myself, I'm just going to face the part, and then I'll set it up against the stop, and then I'll machine my flutes in, and after that I can part off the piece or cut it on the bandsaw, and later on I'll add the crown. This is the holder that I'm going to be using. It's got a 3/16 ball end mill. It's an ER16 with a mini nut. And this is about as close as I'm going to feel comfortable getting it to the chuck jaws there. That's my main limiting factor. With that in mind, I'm going to set up my part so that I won't get any closer than this to the chuck, preferably a little bit farther away. I've sanded and polished the outside of the stock. This is 304 stainless. And I've also made a facing cut because I'm going to set up a table stop against this side. I set my table stop point right there in the middle of the part, which I can see because of the facing cut. And I did that so it doesn't want to move around or vibrate as I rotate the part, and it's also not going to interfere with the cutter. It is going to make it a little more interesting to take this piece out so that I can cut off each piece and then put in the new one. I'll have to open the jaws of the chuck pretty wide in order to kind of slip it in and miss the cutter. It's going to be interesting. Since this is a ball nose end mill and it's round stock, I'm going to use the paper trick to find where my stock is. As soon as it grabs the paper, which it's getting close, there it is, I'll zero the dial on my knee and then move up the thickness of the paper and then the desired depth. I also need to find the edge of the part with the end mill so that I can move in the correct depth, and I'm going to use the paper trick for that as well. This time the end mill will be running. Once I found all my edges and I've determined where I'm going to stop on my cuts, I've gone ahead and put a stop here. And this is the one that comes with the power feed, so it still hits the regular stop on the table, and the issue is that it's a little bit on the small and wimpy side, so I backed it up with this big chunky stop that I had made years ago. That way when I hit this stop, I know it's not going to move. I'm going to be holding these in a 5C collet, and since I have multiple parts, I'll be using a collet stop. This wrench allows me to hold the collet steady so that I can tighten the collet stop. Otherwise the collet stop would potentially back out. Now the stop is nice and tight in the collet, and I just need to set the stop rod to the correct depth. Here I've got my blanks, and I'll just put those in there. That's actually not too far off. Something about there should work nicely. With the final cut, I was trying to go with the same width at the bottom of this slot that I have in between the slots. It's purely an aesthetic choice, certainly nothing critical. To drill my holes, I'm going to use this paddle that I made that fits snugly onto the end of my tailstock quill and allows the dial indicator to bear against it. You can see the slit down here, and there's a socket head cap screw that tightens it onto the quill. And now I can get relatively accurate drill depths on this. They don't have to be super accurate. I mean, they're just pushing on to the potentiometer on the base, but this will at least help me get in the neighborhood. I have all of this set up in such a way that I can withdraw my drill enough that I can put in and remove my workpiece without moving my tailstock. That way I never lose location on my dial indicator. This is stainless, so I'm running it relatively slowly with a lot of oil. Now that I've got the holes roughed in, I'm going to chase them with this flat bottom drill bit. Now, this was a regular drill bit, and all I did was grind it flat on the end. I checked that with a machinist square, and then I added a little bit of relief angle to each of the cutting edges. That way it doesn't drag on the bottom of the hole and squeal. I'm doing this because this has to be a relatively shallow hole, otherwise it risks breaking through the other side, and I'm also going to be chasing this bit with a boring bar to get it up to size. This helps the boring bar a lot because I won't have to take off a ton of material where that angled tip is right now. Flat bottom bits are really no good for drilling a hole from solid stock. There's just no way to keep them centered, which is why I drilled it with a standard drill bit first. Other than that, this operation is exactly the same as the previous drilling operation. The only difference is I'll zero my dial indicator when this edge is at the edge of the hole. That way I know I'm getting to my correct depth. Something that may not be apparent in the rest of the video is that I've been doing my practice cuts on a piece of scrap. So this is one that I scrapped before I even got all of the flutes cut in. I always keep some scrap pieces around whenever I make them because I want to get all of my jitters out and all of my other mistakes out on a piece that's already scrap rather than the ones that are good. If you can see or not, but the hole is pretty nice and flat all the way down to the bottom. For the next bit, I'm finishing up the hole with a boring bar. I need to open up the hole to press in a little plastic insert in there. That pushes over the splines on the potentiometer. Likewise, I need to open up the last 200 thousandths of the hole just for clearance on the nut on the potentiometer. Like before, I started out with one of my scrap pieces, and that way I could dial in everything, make sure that my measurements were correct, and that the fit was good. I've got all the boring done on my knobs, and I've got these plastic inserts ready to go. I'm going to press these in off camera and then put them back in the lathe and drill them to the correct size. Now these are a really nice tight fit. It's actually about 4/1000ths of an inch of interference because plastic squeezes considerably. In fact, on my scrap pieces, I went ahead and drilled the piece beforehand, and I found that the hole collapsed by quite a lot, and I ended up having to re-drill them anyway. So I figured with these, I'd just make them nice and solid and then drill them once. I just drilled until I went all the way through the plastic and I could feel the drill hitting the stainless steel. It's a very obvious difference, as you can imagine. I've adjusted my collet stop to sit a little further out because now it is sitting against that plastic insert. The next step is to cut them to their final length. They're a little bit long right now, a smidge less than a millimeter. And I'm going to do that, and then I'm going to use this form tool that you can hopefully see right here and put a nice little crown on the top. There's going to be a fair amount of handwork there as well, some filing and sanding and polishing, but when is there not? I've got my form tool ready to go, and anytime you use a form tool, you need to run it a lot slower than you would a normal tool. That's because you have an awful lot of tool in contact with the part, and you're much more likely to get chatter. The purpose of this tool is to put a nice crown on the end of the knob. It's purely decorative. It could easily be a chamfer, but I think the crown looks really good. I set the x-axis of my DRO, the crossfeed, at 0 so that I know that I'm going to get the same curve on all three pieces. And then to help me out, I'm going to color the end of the knob with some Sharpie while it's running, and that way once the Sharpie disappears, I know I can stop. That looks pretty decent. I'll go back over it at a higher RPM with a file and some sandpaper to give it a nice polished finish like the sample I just showed you. But I'll wait until I've got the crown put on all the pieces first. For the deburring, I'm just using my triangular scraper again, and really no two ways about it. You pretty much just have to get in there by hand. I could potentially use a round file, but that would probably be a little too aggressive for me. Alright, that looks pretty good. One down, two to go. 21 minutes ago in your time and 5 months in mine, I said that I was going to put these knobs on a base kit that I was building, and in the intervening time, I changed my mind. I decided instead that they would look a lot better on the black Yamaha bass that I have. But don't worry, I've got a really cool idea for the knobs on this kit, and it's going to go really well with the aesthetics I have planned. Stay tuned for future videos. So what do you all think of how these look? Let me know down in the comments below, and while you're down there, hit that like and subscribe button, and thank you very much for watching. I'll see you next time.